Okay, thank you for the very awkward applause. Okay, I want to say, now it's 11:55, so I won't speak too much time to ruin your lunch break. Okay, so I would like to make it short and make it easy to remember. Okay, and after 5 minutes, I would like to say good afternoon, but now I can still say good morning. Good morning, ladies and gentlemen. And it's really nice to be here. My Chinese name is Shang Pengfei, maybe hard to pronounce for you guys to pronounce, so you can just call me Danny if you want to ask me some questions. And as our host says, I'm from the Huawei company. I'm from the Huawei computing product line. And just as you can see in this slide, I'm also an openEuler European advocate. So before my speech really gets started, I have a question. Is anyone here heard the name of openEuler previously? You can raise your hand. Okay. This is my colleague. All right. It's obviously that nobody heard the name of openEuler. So that's why exactly I came here. Also, I come from China. So that's exactly why the reason I came here to make this speech. And now I'm stay in Paris. So it looks like we have more time to communicate about our open source project. And as you can see that openEuler starts with the word open, right? The openEuler is actually an open source software, right? And it's incubated and operated by the Open Atom Foundation. As you can see here, this is the brand of Open Atom Foundation. And you may be curious about what is the Open Atom Foundation. It's actually a foundation, just like the Chinese version of Eclipse. So it's initiated by many Chinese high-tech giants, like you may heard the Alibaba, right? You heard the name Alibaba, Baidu, Tencent, and of course Huawei, right? And many other companies. We gather together. We create we be the initiative of the Open Atom Foundation. And the Open Atom Foundation is established around 2 years ago if I don't make it wrong, maybe it's the June or July of the year of 2020. And last year, we make something very fantastic. Huawei, as the initiative and the creator of the openEuler project, we have already donated the whole project, all the code, all the brand, all the infrastructure to the Open Atom Foundation. So now, just like I said, the openEuler is already incubated and operated by the Open Atom Foundation. And many Huawei employees, they also have two careers or two jobs. One, we work for Huawei, and the other, we work for the Open Atom Foundation. And it's okay, because when I came to the booth in the morning, maybe a lot of you guys here may not heard the name of Open Atom Foundation. So don't worry. We're going to take it step by step, because we already become more and more popular. We have already be a little bit of famous, I would like to say, because the openEuler project and the Open Atom Foundation has already been on the Chinese most famous television program called CCTV. You may heard of it. So it's already been a little bit of popular in China market, but in European, nobody knows it. It's okay. It's actually the openEuler is actually the second time to be published in the European. The last time is my colleagues. It's a she. Her name is Maggie Liang. He do open speech. He do a keynote in the Open Source Summit. And now it's the second time for openEuler to come to the European market to do the same presentation. Okay, and in the morning, some of the, I would like to say, partners or colleagues, they come to our Huawei booth and ask me, you see that? Besides you is the red hat, right? He said, we already have so many Linux distributions in the current market, like Red Hat, SUSE, and also Microsoft is not way from us. So he just curious. We already have so many Linux distributions. Why we need another one, right? So that's also the second reason why I'm talking here. So let's move on. the original Microsoft software version, and also including the Red Hat. It's been very famous. It's been very famous worldwide, like Red Hat, CentOS, SUSE, right? They are already very traditional and famous Linux distributions for many years. But now, just like the title said, the diversified computing era has arrived. The original Linux distributions are dedicated to the server scenario, especially for the local servers, for bare metal servers. So as you can see that the diversified computing era has arrived. So, when new things arrived, so just come up with the new challenges and new opportunities. I would also like to clarify that the openEuler is not actually an operating system. Instead, it's more like a platform to produce, to let our partners, to let the enterprises to produce the operating system themselves. So, just like I said, such as the diversified computing era has arrived, many opportunities and challenges has arrived, like the multi-core. You can't see my mouse. Okay. Sorry. I can't go back to the last page. Can you help me to go to the last page? I haven't finished. Sorry. It's all French. I can't speak French. Go to the last page, or can I?
Maybe this.
Okay, the computer is dead. Maybe this operating system is too hard for this computer. Okay, just like I said, we can continue our presentation. Can you some technical guide to fix this problem, maybe? Okay, as the diversified computing era has arrived, so we have many challenges like multi-core problems and multi-architecture problems, because the x86 is the mainstream architecture for the data center scenario. But now the ARM, the RISC-V, the many other new architectures has arrived and take the place of the x86 platform. So all these things gather together, which means that we maybe need we maybe require a unified operating system to support all these new challenges and new scenarios. Yeah, this is
this one?
Yeah. You can print it. Okay. Let's work our video first. Okay, as you just see the very short video, openEuler is a unified OS. Can we shut? Okay, the music is done. Okay, openEuler is a unified OS for various scenarios, just like I said, for server, for cloud, for edge, and for embedded. 3 years ago, when we decided to open source openEuler, because Huawei we sell a lot of communication devices, right? So actually about 10 or 12 years ago, the Euler OS is an internal OS that's being used in many edge or many data center scenarios, especially for the Huawei internal communication devices. And after 10 years, even 12 years of contribution, then 3 years ago, we decided to open source this project, and the Euler OS became the openEuler project. And at that time, we set a mission that openEuler, we envisions to build a native open source community, and which can help all the industries, especially the Chinese industries, to reduce their development and maintenance costs, and maybe make them easier to get the access to the sustainable evolution of operating system. In China, many enterprises, many industry partners, they said they want to get directly access. They want to get the very quick response from upstream communities. So that's what we do for the openEuler community. And also we can help our partners and enterprises to achieve success in their business. So that's exactly the beauty of the open source project. So that's why we open source the openEuler project. And in order to achieve this goal, the first thing we have to do is to build a transparent and a complete software supply chain for the sustainable OS. And just like I said, there currently in especially most of the enterprises are in the China market, of course. But now we also have some global partners. Now in total we have over 400 enterprises have already joined the openEuler community, including the Baidu, the NetEase, and the Meituan. Maybe you heard these Chinese high-tech giants, and also Jingdong, and many high-tech companies have already joined the openEuler community. And there's one that you may be very familiar with is the Sushi company. They also joined the openEuler community. And in the afterwards slides, I will show you that Sushi has already make a commercial release based on openEuler long-term support version, the community version. So when we come back to the software supply chain, so a community, the first thing we consider came to my mind is we have to build a transparent system. So in openEuler community, we have to do a lot of contributions on this aspect, including the software BOM, the software automatically integration platform, Compass CI, and also we have a lot of tools like code check, the reproducible build, etc. So actually in our world, we not only open up the results of the openEuler software supply chain, but also the supply chain itself. You can find all the source code, all the stuff in our community. So in the last slides, I will show the openEuler official website is openeuler.org. You can log in You can log in our community website to explore, and you can see there are lots of contributions, and there are also some community statistics in our openEuler community. And as I said, openEuler is not only operating, it's also a platform. Now I'm gonna go a little deep dive about the technology part, but don't worry, it will be very quick. So basically in our community, we for technology evolution part, we have two different kinds of versions in our community, but basically it can be combined to one mainline version. As you can see, the upper one is the long-term support version called LTS versions. And every 2 years, we release the long-term support version. And 2 years ago, we released the 20.03 LTS version based on the 4.19 kernel. And now, we just released this year, the latest long-term support version is the 22.03 long-term support version, and it's already based on the latest kernel. A very latest one is not the latest, but the very new one is the 5.10 kernel. And Huawei also take the first place in the upstream upstream Linux community. We do a lot of contributions to just like Intel, like Microsoft. We do a lot of contributions to the upstream community. And the life cycle of the long-term support version is around approximately 6 to 8 years, and they will be discussed under our the technical group in the community to decide whether we can prolong the whole life cycle. So all the decision will be made in our community inside if we can join it. And we also have another innovative version. It's released every 6 months. And in these innovative versions, we're going to publish a lot of new and fancy technologies, and the life cycle is only 6 months. So a lot of enterprises, they will choose the long-term support version as their commercial version to build their own operating system. So actually, openEuler is not an operating system, but it's also a platform to allow our partners and enterprises to build their own operating system. We're very open. We allow, because we use the Mulan protocol, so you can, anyone, any organization, any company, you can use all the, you can find all the source code in our community to build your own operating system. And by the way, the latest one, the 22.03 long-term support version, it can covers the, you can see on the right corner, on the right left corner, is the it can covers the scenario including server, cloud, edge, and embedded. So you can, it means you can cut the scenario until to the ideal situation you wanted. Okay. Now is some very fancy and new technologies of openEuler 22.03 long-term support version. You can also find our, you can also find the technical details in our openEuler.org website. And in this latest version, for example, we bring a lot of new features. Like on server scenario, you can see the green one. We do significantly improve the performance of HPC clusters and adopted decoupled control and compute HCK. If you can see, maybe the people in the backseat can't see it clearly. We use HCK to do this and reduce the computational noise and concentrate resources on the computing plan. And we also improve the MindSpore database performance with Gazilla use model protocol. And on the cloud-native scenarios, the Kube OS, you can see the blue one. The Kube OS, we can support the OS as a container management. And it can be said that the openEuler, as far as I know, is the best in terms of supporting for diversified computing power. And it also covers the multiple scenarios at the same time. And already we have to do a lot of optimization for different application scenarios. So this is a little bit technical, so I will go through it very quickly. If we want to explore it and we want to talk about the details, we can, after this conference. And next I want to show you is the community statistics. As you can see, we have already growing very fast on both community side and business side. The community contributors and downloads are growing very rapidly. You can see the organization contributor and the individual contributor are growing very fast, and also the downloads worldwide. And the business growth is basically the statistics is from the China market, because we just like I said, we just come to the Europe, so we just started in the Europe market. And in China, and according to the third party statistics, we estimate that the openEuler series operating system. Why I say openEuler series operating system? openEuler series operating system means not only the community version, I mean the long-term support version, it also include a lot of OSV's commercial releases like SUSE, like Baidu Linux, Jingdong Linux, the lots of commercial releases gathered together will occupy around 25% of the Chinese market share by the end of 2022. And just before I make this presentation, I just use my Chinese social media called WeChat. I saw a lot of advertisement in my WeChat social media. I saw that we have already achieved in many industries. We have already achieved the first place in many industries, like the finance, the carrier industry, and in finance in many fundamental industries like energy, electricity. A lot of OSVs release their commercial version based on the community version. So in China, market we are a little bit famous, but in Europe we just gonna take it step by step, and that's we also need some like the local European service provider, the operating system vendor. Also, we need some help from the research center, some organizations in European. So we really do need some local partners. So if we are interested, we can talk later. And now is the commercial releases. Now it's already over 20 mainstream OSVs have released the commercial distributions to cover the various scenarios and provide the diverse industry solutions. And you can see the first one is Baidu Cloud Linux, and the second is the China Telecom, third is the China Mobile, and the fourth is the China Unicom. So, and also in the second line you can see SUSE. So SUSE also already released openEuler about 1 year ago. Now SUSE also want to do business, want to do some localization in China market. So basically, openEuler will count more OSVs, just like I said, more OSVs, more service provider to release the distributions and contribute to the openEuler community together. Just like I said, open source project is very charming because we can reduce the development and maintenance cost. So we just build up a platform and we gather 400 enterprises to join the community. We also want more European enterprises to join the community, and we contribute together, we create together. Then we can be an unstoppable force to unleash the digital power. So, and you can see changes happen every day in our community. openEuler is gradually become its own self-circulation system for a sustainable future, and there are a lot. We have already approximately 100. Now it's 98. Six means special interested groups, and in these 6, there also contains a lot of directions like the cloud native direction, the kernel direction, the RISC-V direction, the ARM direction. There are a lot of different technology directions are also included in our openEuler 6. And now there are a lot of issues appears day by day. So actually all our properties, I would like to say the source code have been like incubated and operated by the openEuler Foundation in a Chinese GitHub named Git. But we also have a mirror in the GitHub, so you can search our source code from the openEuler.org. It has 2 entrances. One is Git, a Chinese version of GitHub, and you can also find our source code and our latest. They're automatically. How can I say? They're all the codes, all the projects, all the discussion from Git will be automatically transferred to GitHub. So we do have a mirror in the GitHub. For the global developers. And now we also initiate some social media. Now we have 4: Twitter, Reddit, LinkedIn, and YouTube. You can follow our social media, and you can subscribe our social media account, and also you can ask questions. You can ask your request about how to build a better community for the openEuler, so you can subscribe it. And last, I want to say thanks for listening, and hope we can work together to improve the open source project together. And I hope I don't occupy too many time for you to have a lunch break. Thank you. If you have any questions, you can ask me directly, or we can talk afterwards. Okay? Thank you. Okay, so next will be my colleagues.
Alors, je comptais vous demander si je devais continuer en français ou en anglais, mais étant donné que je devais devoir être très concis, je vais me permettre de parler en français et de sauter énormément de slides. Est-ce que c'est bon? Ok. Alors, je vais commencer par la conclusion et dire que donc, j'étais venu ici pour vous présenter le framework MindSpore, qui est un framework pour l'IA. Et ma conclusion, c'était que c'est pas très connu ici. Je voulais venir vous en parler pour vous convaincre, pour tenter de vous convaincre de l'essayer et même peut-être d'y contribuer dans la mesure où c'est un framework open source. Alors, très rapidement, je vais juste passer en plein écran. Alors, très rapidement, j'ai oublié de me présenter, du coup, très rapidement, je suis Arino Merzanato, je suis ingénieur de recherche au centre de recherche de Huawei ici à Paris, dans l'équipe DPSL, Distributed and Parallel Software Laboratory. Et donc, on travaille entre autres sur MindSpore dans notre équipe. MindSpore qui est un framework pour l'IA, dont le but est d'être utilisable dans all scenarios, c'est-à-dire aussi bien dans le cloud, sur de l'edge, sur des téléphones mobiles, sur une grande variété d'architectures, du CPU, du GPU, de la SAND. C'est notre architecture pour accélérateur chez Huawei, et sur une grande variété de systèmes d'exploitation. Donc c'est pareil que les autres concurrents, TensorFlow, PyTorch, c'est du Python pour les développeurs en front-end et le back-end étant C++. On a de la documentation si vous voulez si vous voulez faire de la migration depuis PyTorch ou TensorFlow. On a même des outils automatiques pour faire ça. C'est prévu pour être facile à débugger. On a les réseaux de neurones typiques sont implémentés. On a énormément de modèles pré-entraînés. Niveau collaboration, c'est pas très connu en Europe, mais on a déjà pas mal de collaborations en Chine avec pas mal d'instituts de recherche. En Europe, on a quelques universités qui commencent à collaborer avec nous, comme à Édimbourg. Ici, à Paris, on en a aussi une. On a beaucoup de contributions à la science d'un point de vue publication scientifique aussi. Donc j'espérais avoir beaucoup de temps pour vous convaincre d'essayer et de contribuer à MindSpore. Et pour cela, je comptais parler des nombreuses optimisations automatiques qui se passent à l'intérieur de MindSpore. Donc on en a tout plein, on a de parallélisme automatique, des optimisations sur la mémoire, du pipelinage. Et ce sur quoi moi je travaille, c'est la fusion de noyaux de calcul. Parce que donc, pour un peu de contexte, dans les réseaux de neurones, on a des graphes des computational graphs. Donc ces graphes, ce sont tous les opérateurs qui sont utilisés dans le réseau, qui sont représentés sous forme de graphes. Et il se trouve que l'exécution naïve, ce serait d'exécuter chacun de ces opérateurs un par un. Et il se trouve que souvent, on peut optimiser ça en faisant ce qu'on appelle de l'operator fusion. Je vais passer sur tous les détails de ce graphe-là. Et donc le problème avec cette histoire d'operator fusion, c'est que selon l'architecture qu'on cible, si on veut faire exécuter sur CPU, du GPU ou alors des accélérateurs dédiés, on ne veut pas générer le même code à la fin parce que chaque architecture a ses propres spécificités. Sur CPU, on va peut-être vouloir optimiser la localité des données. Sur GPU, on va vouloir maximiser le parallélisme, alors que si on a un accélérateur, il se trouve qu'il aura peut-être une instruction dédiée, par exemple, pour la multiplication de matrices. Et le problème, c'est comment est-ce qu'on peut faire pour cibler toutes ces architectures à partir d'une même entrée, d'un même programme d'entrée. Il y a plein de façons de faire ça. Nous, ce qu'on utilise ici à Paris pour faire ça, c'est le modèle polyédrique. Donc c'est un modèle qui est bien connu en compilation. L'idée, c'est d'avoir en entrée des boucles qui sont régulières. On les analyse, on les représente sous forme mathématique. Et après, on essaie de les transformer d'une manière ou d'une autre selon ce qu'on essaie de faire. Et à la fin, on régénère un code. Donc ça, ce sont des choses qui sont assez bien connues en compilation. Pour passer très rapidement, il y a énormément de ressources disponibles aussi bien d'un point de vue développeur que d'un point de vue utilisateur final. Mais le problème, c'est que c'est bien connu quand on a une seule architecture à cibler, mais pas quand on a plusieurs architectures à cibler avec le même programme. Donc pour faire ça, dans MindSpore, on a ce qu'on appelle l'AKG, l'Auto-Kernel Generator, qui utilise ces techniques de compilation polyédrique. Donc c'est capable de prendre en entrée ce que le programme représenté dans les frameworks d'IA. Ensuite, on a énormément de passes de compilation. Donc là, c'est juste la liste. C'est même pas la peine de regarder en détail toutes les passes là. Il y a énormément de passes, premièrement pour faire la conversion vers le modèle polyédrique et après l'inverse. Et même une fois qu'on... Donc là, toutes ces passes-là, c'est pour rien que la conversion, le pré-processing, le post-processing. Et même si on s'intéresse plus particulièrement au processus de compilation polyédrique, on a encore plein de passes qui sont nécessaires selon l'architecture. Donc justement, là, les codes de couleur, c'est pour chacune des architectures données. On a différentes transformations à appliquer sur notre programme. Alors, comme je disais avant, le modèle polyédrique, c'est quelque chose qui est très bien connu en compilation, mais c'est quelque chose de très général. Et donc, quand on veut s'attaquer à plein d'architectures données, il nous fallait plus de contrôle. Et donc, désolé, c'est un peu décousu parce que j'ai plus beaucoup de temps. Et donc, ce qu'on a proposé ici à Paris, c'est d'intégrer un moyen d'écrire les architectures données, à partir des architectures données, d'essayer de guider le processus de compilation polyédrique pour le forcer, selon l'architecture sensible, à sortir une transformation légèrement différente. Donc on a testé ça par exemple pour forcer le processus à générer quelque chose de plus adapté au GPU. Donc selon les réseaux ciblés, on a un petit impact, mais sur certains, on peut voir qu'on avait réussi à avoir jusqu'à un speed-up de x7, donc 7 fois plus rapide que ce qui se faisait précédemment avec la méthode générique. Donc, ça, c'est juste l'une des choses qu'on est capable de faire maintenant. On a plein d'autres idées, on a plein d'autres pistes à poursuivre. Par exemple, ce que j'ai présenté avant, c'était quand on s'attaque à des réseaux où les matrices à l'intérieur sont denses. Parfois, on sait que c'est aussi quelque chose de connu en compilation. Le calcul sur des matrices sparses ne se fait pas forcément de la même manière que sur des matrices denses. Une autre piste à explorer, c'est que typiquement, les réseaux de neurones, il y a énormément d'approximations à toutes les étapes, alors que le processus polyédrique se veut sans approximation. Donc l'idée serait peut-être de trouver un moyen de rajouter de l'approximation pour aller encore un peu plus vite. On n'est pas les premiers à s'être intéressés à comment utiliser le modèle polyédrique dans l'IA, mais par contre, à l'heure actuelle, à ce qu'on sache, on est les plus avancés dans la mesure où les autres frameworks ne font pas de la génération de bout en bout pour plusieurs architectures. Voilà, c'était un peu... J'ai essayé de faire très rapidement, donc j'espère que je vous ai convaincu que il y a beaucoup de choses à faire en optimisation. On a besoin d'aide pour continuer à optimiser tout cela. On a plein de pistes à explorer. Le code est open source, donc vous pouvez le trouver sur Gitee, et il y a des mémoires sur GitHub, aussi bien pour MindSpore que pour AKG, le sous-projet qui s'occupe de l'optimisation des noyaux de calcul. Donc si vous avez des questions à ce sujet-là, je vous invite à venir nous voir à notre stand Huawei.
Très bien, merci beaucoup.